Okay, everyone, settle down now. Good morning, class. It's either Kenny here. Today is April 21st, Monday. And I found a super interesting paper from the archives for us today. It's all about making our computer friends a bit smarter, you know? The title is, It's All Connected. A Journey Through Test-Time Memorization, Attentional Bias Retention, and Online Optimization. Well, that's a mouthful, isn't it? The crawl is. Merci for doubting thigh. Or 4.13,173 run. It's long. This paper comes from some clever folks at Google Research. So, what problem are they trying to solve? You ask. Now imagine you may learn. Very long storybook. Sometimes even grown-up computers, like the ones called transformers, have trouble remembering what happened way back at the beginning, especially if the story is super long. Like, they can get slow or need lots of space to remember everything. This paper wants to help computers remember things better, over longer periods, just like we do. They talk about something called, attentional bias. It's like how sometimes you pay more attention to a shiny red toy than a bright blue one, right? Computers also need to decide what information is important to focus on. And they also talk about retention, which is like how well we hold onto memories instead of forgetting them. So the researchers came up with a new recipe, a framework they call Miras. Think of it like a set of building blocks for making smart computer brains. Architectures, as they call them. Miras lets builders choose different ways for the computer to pay attention. That's the attentional bias. Then different ways to remember things, the retention game. They even made 3 new kinds of computer brains using Miras. Memora. Aren't those fun names? Now, where could we see this in real life? Let's think of some examples. Okay, first one. Recommendation systems. You know how YouTube or Netflix suggests videos or movies? Well, sometimes they only remember what you watched recently. With better memory like from Miras, they could remember that cartoon you loved months ago and suggest something similar, even after you watched tons of other stuff. That'd be neat, right? Second example. Imagine talking to a helpful robot about a big school project. If the chat goes on for a long time, your robot might forget what you decided earlier. These new ideas could help you remember the important details from start to finish, making it much more helpful. And let's see a third one, self-driving cars. Those cars get super good memories. They have to remember a stop sign they saw a minute ago. Or maybe a bicycle that turned a corner. Better memory helps them understand everything happening around them over longer drives, which is super important for safety. So how does this compare to other technologies? Well, we have transformers, which are really smart. But like we said, they can struggle with super long information. And we have older types, like currents, which are often faster for long things, and maybe not always as powerful or great at remembering specifics. These are models like Moneta, Yaad, and Memora are trying to be the best of both worlds. They want to be fast and efficient like currents, but also really good at remembering and understanding context. Even better than transformers for certain long tasks. The paper shows experiments where the new models did really well, sometimes even better than the famous transformers, especially on tasks needing good recall of long information. Wow. So it's all about finding better ways for computers to learn. pay attention and remember, just like we do. Isn't that exciting? Okay, that's all for today's paper. Great job listening, everyone.